Welcome. Today we're going to explore two important NoSQL document databases that you can use on Google Cloud, MongoDB and Firestore. MongoDB is available through Google Cloud's Marketplace as a partner offering, while Firestore is Google Cloud's own native document database. Whether you're building a web application or mobile app, you'll eventually need to choose between these databases for storing semi-structured data. Let's start by looking at MongoDB's options. When you search for MongoDB in the Google Cloud Console, you'll find it in the Marketplace. Scrolling down the page shows us two main pricing models, one for dedicated clusters and another for pay-as-you-go Atlas pricing. To better understand these options, let's look at MongoDB's documentation on their pricing page. MongoDB offers three main choices through Google Cloud. First, there's a free experimental environment that's serverless and perfect for testing. Second, there are dedicated options with different levels of computing power. If we look at the dedicated pricing for Google Cloud, we can see various cluster tiers with different amounts of CPU cores and RAM, all using SSD storage. The flexibility here is impressive. For example, if you need 4 CPUs, 16 gigabytes of RAM, and 400 gigabytes of storage, you can configure exactly that. The basic price for an M40 option starts at 86 cents per hour, and the minimum is about $57 per month for dedicated clusters. The third option is Serverless, which uses consumption-based pricing. This means you pay based on three things: how many read operations you perform, how many write operations you make, and how much data you store. When we compare this to Firestore's pricing, we see some interesting similarities. Both charge for reads, writes, and stored data. However, there are some key differences. Firestore charges more for operations but offers cheaper storage at 18 cents per gigabyte compared to MongoDB's higher rate. Let's capture some important observations about these pricing structures. For the serverless options in both databases, you don't select CPU and RAM configurations. Those are handled automatically. The dedicated MongoDB options are quite affordable, with that $57 monthly price point being reasonable even for smaller projects. MongoDB Atlas Serverless offers the lowest per option costs for reads and writes, while Firestore provides the most cost-effective storage solution. All three options include auto-scaling storage, making them flexible as your needs grow. To start using MongoDB through the Marketplace, you'll need specific permissions. Click Subscribe, and you'll see what permissions are required. These need to be set up at either the billing account or organization level. For example, you might need the Consumer Procurement Administrator role. If you're working with an administrator, you can copy the exact permission name from the interface and request it from them. After your permissions are in place, which usually takes a couple of minutes to activate, you can subscribe to MongoDB. When choosing the pay-as-you-go option, you'll see a calculator that helps estimate your consumption costs. This calculator is just for estimation. You're not committing to any specific amount. After reviewing and accepting the additional terms and selecting your billing account, you can complete the subscription. Once subscribed, you'll manage your MongoDB setup through MongoDB's own interface. You can log in using your Google identity, which makes the process seamless. When setting up your database, you have two main paths: serverless or dedicated. Let's look at the serverless configuration as an example. Here's a helpful tip. Always check the advanced configuration options, even if you don't plan to use them all. For instance, your choice of region affects pricing. Using the Iowa data center can be more cost-effective than choosing Los Angeles. During setup, you can also select your MongoDB version, configure backup settings, and specify storage options. Remember that increasing storage will increase your costs. The pay-as-you-go plan charges hourly for active clusters, but you don't need to commit to a long-term contract. Setting up a Firestore database is notably simpler than MongoDB. You only need to configure a few basic things. Give your database a name, choose a location, and set up some basic networking and security rules. Let's walk through an example where we demonstrate a database called Demonstration. When setting up Firestore, you can choose between regional and multi-regional configurations. The multi-regional option gives you a higher service level agreement, or SLA, and offers two choices: Europe or United States. For a fair comparison with our MongoDB setup, we'll select a single region, US Central 1. To make initial testing easier, we can enable test rules that provide simple database access for the first 30 days. At this point, we have both databases ready: our serverless MongoDB Atlas instance and our Firestore database. Both platforms provide various tools for managing your data, including options for security configuration, data import-export, and analytics insights. Looking at the setup process overall, both serverless options require minimal configuration steps. However, if you choose MongoDB's dedicated option, you'll need to do more setup work, which is expected when comparing serverless to traditional hosted solutions. Now let's explore how to actually use these databases. We'll do this using Python in a development environment. To keep things simple, we'll use Google Cloud Shell and its built-in editor, which provides a free IDE where we can connect to both databases. First, let's understand some common terminology. Both MongoDB and Firestore use the term collections to organize their data. Within these collections, you store documents. This consistent terminology makes it easier to work with either database. Both databases also support flexible, semi-structured data, meaning your documents can have nested fields and repeated records without being forced into a rigid structure. The flexibility in both databases means that documents within the same collection can have different structures. For example, one document might have certain fields that another document doesn't have. This is a key feature of NoSQL databases that sets them apart from traditional relational databases. However, this flexibility means you'll need to use different querying approaches than you might be used to with SQL. You'll search for specific fields and values rather than using traditional SQL queries. Let's start with Firestore. To work with Firestore, we need to use the Firebase admin module. After installing the Firebase admin library with a simple pip install command, we can create our first example. When working in Google Cloud Shell, we have an advantage. We can use the built-in authorization since we're already logged into Google Cloud. This mirrors how authentication would work if you were running your application in Google Cloud services like Compute Engine or Cloud Run. When we run a Python script successfully, it creates our first record. We can verify this by looking in the Firestore console. You'll see the user's collection and the document we just created. To demonstrate the flexibility of Firestore's schemaless nature, let's modify our example by adding a new field. We'll add a beta field to one document but not another. When we add this field to Jane's record with beta set to true, while John's record doesn't have this field at all, we're showing how NoSQL databases can handle varying document structures within the same collection. Now let's look at MongoDB. The setup process requires a few more steps. First, we need to configure the connection through MongoDB's Connect interface and create a user. MongoDB offers various connection methods, including shell commands, but we'll focus on using Python with the PyMongo library. When setting up MongoDB connectivity, we often face a few common challenges that are worth understanding. Initially, our code might try to connect to localhost, so we need to update the connection string to point to our actual MongoDB instance. We also need to handle networking properly by specifying that we want to use SRV records in our connection. Another important setup step for MongoDB is configuring network access. We need to add the IP address we're connecting from to MongoDB's allowed IP list. When working from Cloud Shell, we can find our IP address by making a simple HTTP request to a service like HTTP bin's IP endpoint. This IP address needs to be added to MongoDB's network access configuration. Finally, we need proper authentication. This means creating a user with appropriate permissions, typically read and write access to our specific database. Once we have these pieces in place, correct connection string, network access, and authentication, we can successfully connect to MongoDB. When we run similar code with MongoDB, we can create and read documents just as we did with Firestore. The syntax is different, but the concept is the same. We can create collections, add documents, and those documents can have varying structures. For example, we can create the same type of flexible schema where some documents have additional fields that others don't. Both MongoDB and Firestore exist within larger ecosystems that offer additional features and capabilities. MongoDB's ecosystem, which you can explore on their homepage under Products, has been expanding into cutting-edge areas like AI. They've introduced vector search capabilities, and they offer various search and streaming applications. MongoDB also maintains a wide network of partnership integrations, allowing you to connect your database with many other services and tools. Firestore, on the other hand, is part of Google's Firebase ecosystem. While you can use Firestore as a standalone database, it's designed to work seamlessly within the broader Firebase platform, which caters specifically to mobile and web application development. If you visit the Firebase homepage, you'll discover a rich set of features, including machine learning capabilities and numerous ready-to-use extensions. For example, you can easily integrate Algolia for advanced search functionality or Stripe for payment processing. This makes Firebase and Firestore particularly attractive if you're building mobile or web applications that need a complete ecosystem of services. For operational costs, if your primary concern is the cost of database operations or reads and writes, MongoDB Atlas Serverless offers the most economical choice. For storage costs, if you're storing large amounts of data, Firestore provides better value with its lower per gigabyte storage cost. For ease of setup, Firestore wins with its simpler, more streamlined configuration process compared to MongoDB Atlas. For ecosystem choice, this is more subjective and depends on your specific needs. MongoDB's ecosystem focuses on database-centric features and integrations, while Firebase Firestore provides a more comprehensive platform for application development. If you specifically need a dedicated server, MongoDB's dedicated cluster option stands in its own category as Firestore is purely serverless. The good news is that both databases are excellent choices for NoSQL document database needs. Your choice might depend more on your specific use case than on any significant technical limitations of either platform. Remember that you can start with the serverless options for both platforms, which provide a low-risk way to test and evaluate which database better suits your needs. Both platforms offer free tiers or experimental environments, making it feasible to try both before making a final decision. If you have any questions, feel free to ask in the comment section. Also, if you'd like to support the channel, consider starting a free trial of our new design tool, which is linked in the description, and let us know what you think. Today's code will be in the description as well. Thank you very much for watching to the end, and please enjoy responsibly.